Section 1.3, which is sine, cos, and tan of obtuse angles. Okay? First, we're going to go through the definition of obtuse angles, and then we are going to define what is the sign of the sine, cos, and tan. If the angle is in the first quadrant or the second quadrant. We're going to talk about the quadrant in a second. So before I get to there, let's define a new definition, which probably you know from grade 9. It's called acute angle. We define an acute angle is the one which is less than 90 degrees. Remember, all the angles we're talking about are positive angles. So any angle between 0 and 90 is called an acute angle. So remember this definition, acute angle, angle between 0 and 90. The next definition we are going to call is obtuse angle. Is a type of angle that is between 90 and 180. So any angle between 90 degrees and 180 is called an obtuse angle. You may say, what about angle 90? Angle 90 is called a right angle. Angle 80 is called a straight angle. So 90 and 180, they already have a name associated with them. Any angle between 90 and 100 we call obtuse angle. In a Cartesian coordinate system, which you have x and y, this is your y, this is your x. The region is divided into 4 pieces or 4 quadrants. This part, where the x is positive, here, x is positive, y is positive, is called quadrant 1. So please, copy it, quadrant 1. This region where x is negative here, and x is positive here, and y is still positive is called quadrant 2. And when you go counterclockwise, this one, when x and y are negative, is called quadrant 3, and this one is called quadrant 4. We are not going to talk about quadrant 3 and 4, so forget about 3 and 4. We are going to talk about only quadrant 1 and 2. Okay? So in quadrant 1, again, x is positive, y is positive. This is quadrant 1. In quadrant 2, x is negative, and y is positive. So any point here has x negative, y positive. Now you will understand in a second why do we call these quadrants and why are we working with quadrant 1 and quadrant 2. We define the trig ratios, okay, using any point x, y in our coordinate system here. Meaning, if I have a point P which is coordinate x, y, okay, I can connect it to the origin which is here, which is point A. The coordinate of point A is 0, 0 because that's the origin. And the coordinate of point P is xy, can be any number. Now, if x and y are positive, then we know that point P is in quadrant 1. If x and y are x is negative, while y is positive, we know it's in quadrant 2. And if x is negative, y is negative, then it's quadrant 3. And if x is positive, y is negative, is going to be in quadrant 4. Now, we are going to use Pythagorean theorem, okay, and the right triangle to somehow relate the trig ratios with the coordinate of point P. If you look at the triangle P, A, and B here, then you will see that this is a right triangle. The reason it's right because this angle B is 90 degrees. Now, remember that point P has coordinate x and y. So this means that the x coordinate of the point is x and the y coordinate is y. Now, if I find the angle A here, which is right here, then I can write that sine A by definition is equal to opposite over hypotenuse. What is opposite to angle A here? X, agreed? Y divided by a hypotenuse. Hypotenuse is this guy. But I have no idea how much is the measure of this side here. To find that one, I'm going to use the Pythagorean theorem. In a Pythagorean theorem, I can say that the hypotenuse is the sum of the squares of the other two sides. So I can write that R is equal to what? X squared plus Y squared. This is my R squared. Agreed? The hypotenuse squared is the sum of the square of the other two sides. So I can say that R is really square root of X squared plus Y squared. Agreed? So sine A is the opposite, which is Y divided by R, which is square root of X squared plus Y squared. Or I can simply write Y over R, if you know R is square root of X squared plus Y squared. Now, the same way, what is cos A? By definition, cos is adjacent over hypotenuse. Now, adjacent to this angle is this guy, which is your X. Because remember, this one is the X coordinate of point P. So it's going to be X divided by hypotenuse. Hypotenuse is R, which is square root of X squared plus Y squared. So I can write that cos is X divided by R, which is equal to X divided by square root of X squared plus Y squared. Okay? Now, the last one is tan. What is the definition of tan? It is opposite over adjacent. Okay? So I can write that tan A is equal to, what is opposite to angle A? Y divided by X. And if you look here, we just came up with the same formulas that we have here. We just did it right here. Now, you may say, what is the importance of coming up with all these formulas? Is the following. If I know the angle, where the angle is located, either in quadrant 1 and quadrant 2, I can tell you what is the sign of the sine A or sine B, cos A or tan A. For instance, if the angle or the point is in quadrant 1, what is the sign? I'm not talking about the trig sign. I'm talking about the sign, positive or negative, of sine A, or that angle. If it is inside this quadrant. Remember, we said that sine is Y over R. We know that R cannot be negative. But X in quadrant 1 is what? Positive or negative? Positive. So positive over positive gives you? So it means that sine of any angle, if the point is in quadrant 1, is always positive. Now, let's look at quadrant 2. If the point is quadrant 2, remember the sine of any angle is going to be Y divided by R, which is the hypotenuse. Now, in quadrant 2, is Y positive or negative? Look, if the point is here, then the Y is this one. Is Y positive or negative? Positive. Is R positive or negative? No. R is always positive. Length is always positive. So R is always positive. What is positive over positive? Positive. So it means that if the point or the angle is in quadrant 1 or quadrant 2, sine is always positive. Now, let's look at cos. If the angle or the point is in quadrant 1, remember that cos is X over R. we know that x is positive in quadrant 1. We know that r is positive in quadrant 1. So what is the sign of, meaning positive or negative of cos of the angle? Positive. Now let's go to quadrant 2. Okay? Is x positive or negative here? Negative. Is r positive or negative? Positive. So what is x over r? The sign. Positive or negative? Negative. So if the angle is in quadrant 2, the cos of the angle is always negative. Now let's look at tan. Tan, if the angle is in quadrant 1, okay, is x positive or negative? Is y positive or negative? Why is this one? Is y positive or negative? Positive. So positive over positive? Positive. So tan is positive. Now if the angle is in quadrant 2, okay, is y positive or negative? Is x positive or negative? Negative. So what is y over x? Negative. So tan is negative. Okay? So the result is that if angle A is obtuse, remember obtuse means between 90 and 180, okay? Then x is negative, then it means that cos and tan is going to be negative. So if A is obtuse, just remember this one, that sine is positive, cos is negative, and tan is also negative. So remember this one. So if you use your calculator, sine 123 is going to give you 0.84. Which you can see is greater than 0, positive. If you use your calculator, cos C is going to be negative 0.54. And you can see this is negative, which is correct, because the second quadrant cos is always negative. And if you use your calculator, tan 123 is negative 1.54, which is less than 0, which is correct. Because the second quadrant, we said that x is negative, so y over x is going to give you a negative number. Now we are going to define a new phrase here, meaning supplementary angles. Supplementary angles are the ones that their sum is 180 degrees. So 90 and 90 are supplementary. 20 and 160 are supplementary. 30 and 150 is supplementary, and so forth. So when two angles, they add up to 180, we call them supplementary. For instance, give you example, 10 and 170, 20 and 160, and so forth. As long as the sum is 180 degrees, we call them supplementary angles. The first one says the sine of acute angle, P, so P is between 0 and 90, is 0.65. So this means that sine P is 0.65. Okay, the next one, the cos of angle R, again is acute, is 0.22. So I'm going to write cos of R is 0.22. Then I use the inverse again. If you use the inverse cos, you will find that R is 77.3. Now, again, I need the supplementary angle. So I'm going to subtract it from 180. And I'm going to get 102.71. Now the last one, the tangent of angle S is 0.44. So I'm going to write tan S is 0.44. If I use the inverse of the tan on your calculator, I will find that S is approximately 23.75. And if I subtracted from, again, 180 to find the supplementary, I will find that S is 156.25. Again, using your calculator, sine 110 is 0.94. Okay, so 0.94 is the sine. The first number I write is sine, the second one is cos and tan. Cos 110 is negative 0.34. And the tan is negative 2.75. This is for first one. For the second one, sine of 154 is 0.44. Cos of 154 is negative 0.9. And tan of 154 is negative 0.49. For 102, if you use your calculator, sine is 0.98. Cos is negative 0.21. And tan is negative 4.7. Now, if you look at the cos and tan, you can see cos and tan, which are the two numbers at the bottom, they are always negative, which is correct. And the sine, which is the first number, the first row, is always positive, which is in agree with what we found previously. Now, by looking, sine 35 is in the first quadrant, so we automatically know that this has to be positive. Tan 154, because 154 in the second quadrant has to be negative, and cos has to be negative 2. Now, what is sine 35? How much is it? 0.57. What is tan 154? Negative 48. And what is cos 134? Negative 0.7. And you can see without even evaluating, our prediction about the sign is correct. Positive, negative, negative. Okay, so the first part of the problem, part A, says sine A and a point P. This means that I'm going to connect point P to the origin, which is going to be my terminal angle, and this is the angle that I have to find. So PA is my terminal arm, and the angle that I have to find is this angle. To do that one, remember what we said at the beginning of the class, that sine of any angle A, if the point has the coordinate x and y, is what? Y over R. Excellent. Now, if you look at point P, okay, what is the y value? 3. 3 over, and what is R? Remember, R is x squared plus y squared. Now, x squared is negative 4 squared, which is what? 16. And what is 3 squared? 9. What is 16 plus 9? 25. What is square root of 25? 5. So your answer is 3 over 5, which if you simplify is going to be 0.6. And you can see that sine is positive, which has to be. So we found that sine A is going to be 0.6. Okay, let's do the part B. We know that Q is the coordinate of Q, if you look at the diagram, is 1, 4. Okay, so I write 1, 4 beside it. The reason is that if you look here, Q says 1, 4. Now, this means that x is equal to 1, y is equal to 4. The first number is always x. The second number is always y. Now I have to find r, the length of the terminal arm. We know that r is square root of x squared plus y squared. Now, x squared is 1 squared, which is 1, plus y squared. Y is 4, so y squared is 16. So the answer is square root of 17 for r. Now, if you go back to your notes, you will see that cos of any angle, okay, in general, with point P, X, Y, is given by what? What is cos? The formula. X over R. Excellent. Now, we know X is 1. It's here. And we know R is square root of 17. So I say cos A is 1 over square root of 17. If you simplify this one, you get 0.2425. In this case, we know that R is 6,3. If you look at the diagram, this is R, 6,3. We know that X is 6, Y is 3. So R is square root of X squared plus Y squared, which is 6 squared, 36, plus Y squared, 9. So the answer is 45. Now, if you refer back to your note, we said that tan of any angle based on the point is y over x. So I can say tan A is y is 3 divided by x, which is 6, which is 1 over 2, which is 0.5. In fact, we didn't need to even find r, because for tan, we don't need r. So really, I mean, you don't need to find r at all. Just y and x is enough to find tan of the angle. Now, part D. We have point S, which has the coordinate -5 and 6. We are supposed to find cos A. I know that x is -5, y is 6, and r is square root of x squared. -5 squared is 25, and 6 squared is 32. So the answer is 50, 61. So square root of 61 is r. Now, knowing this one, then cos A, by definition, is x over r, which is -5 over square root of 61. You can either leave it like that, or you can say negative 0.6402. Again, you can see that point S is in the second quadrant. We found out that the cos of angle in the second quadrant is going to be always negative. Yeah, the square root of 6 is 36, so this is 36. 25 plus 36 is 61. Thank you. Okay, for point T, we know that x is equal to 4, and y is equal to 7, and r is equal to square root of 4 plus square root of 7, which is 16, plus 49, which is going to give you square root of 65. Now, to find sine, we know that by definition sine A is y over r. We know y for the point T is 7 divided by square root of 65. If you simplify this one, you get 0.8682. which as you can see is positive, which is in agree with sine A for a point in quadrant 1, has to be positive. Okay, the first question. I know that y is between 0 and 180. If I tell you sine y is 0.32, how many answers do you get?
2.
Okay? Now, to do that one, I'm going to use the calculator and I'm going to find the inverse sine to see what angle gives me 0.32 for the sine. If you use your calculator, you will find that y is approximately, how much is it? If you use your inverse sine? 18.7 degrees. Now, if you remember that in quadrant 1 and quadrant 2, sine has the same sign, meaning they are positive. So this means that the complement of this angle also have the same sign. What is the complement of 18.7 is 180 minus 18.7, which is going to give me 160.3. So this means that if I have sine y is 0.32, I will get two answers, 18.7 and 161.3. And you can check it using your calculator to see what is sine of 161.3. You will get the same answer. Okay, part B, sine y is 0.23. Without doing any calculation, I know I'm going to get two answers because in quadrant 1 and quadrant 2, sine is positive and 0.23 is positive. So if I use the inverse function on my calculator, I get that y is equal to, what is y? 13.3 degrees. And then if I find the complement of this angle, meaning 180 minus 13.3, I'm going to get what number? 166.7 degrees. And if you want to make sure that you are right, find sine of 13.3 and 166.7, and you will get both of them. They give you 0.23 as the answer. Okay, the next one, C, cos y is negative 0.45. How many answers I get? I will get only one answer because cos is negative only in quadrant 2, between 1 and 2. It's only quadrant 2, so there is no complement exists, so there is only one answer.